Okay, let me talk about the conservation of energy, second order of fluid moment. Sorry that my handwriting is really tiny, otherwise it will be impossible to fit all the information in it. So let's start with a general way to take a moment, which you can see from the video that I made before. The second moment is effectively the kinetic energy. So phi 2 will be V1, VI. We added half ms because I wanted to make it resemble the kinetic energy. And from the previous video, first order, we know that the VI is phi I, and this V to the third V to the third will be VI VJ, and we know the derivative of V squared will be this. So we have that, and based on what we have here, the del Vn V2 will be 2V, right? So it will end up become V dot V cross B. We know that V cross B is perpendicular to V, then that will end up become 0. So we put all of that into this equation. So this will be here, and this will be here, and this, because the derivative will be 2V, then we'll end up having this, and we know that the Lorentz force term will vanish, so it becomes 0. And we just plainly put this down here because it's we haven't determined what is collision operator we're going to use. So from the previous video, we see that we define the velocity as the overall motion term and a thermal motion term. So this is like U is like all moved together, and W is like the random motion around it. Around is like a thermal motion. So we know that the average over V will be U. Here is the definition of how we're going to do averaging. From the previous video, we know that we will end up, if we average to the second order, we will have Ui Uj plus Pij over Ms Ns. The V to the third is much more involved. So if we break it up to U plus W, then we have U plus W multiplied U squared plus 2UW plus W squared. So we ended up left with 6 terms. So U squared, U2UW, UW squared, and the WU squared, 2W W squared. So that's all 6 terms. You can check it and pause it to see if it's correct. So this term we'll just put into the next equation. And this term, because the average of W is 0, since it's 2UW, then there's only one W here, then we'll end up having a 0. Similar idea here, WU squared, so the average of W is 0, then this term vanishes as well. So the UW squared is, W squared can be considered as the sum of all the diagonal term of the pressure tensor. So it will become the trace of the pressure tensor over NSMS. So it becomes 3P over NSMS. And this term will become this. This similar idea apply to this, but the W is not in the same subscripts. So one is I1, another is J, and so we'll have U, P, I, J. So it will become a vector multiplied by a tensor, or a matrix, as you may think. And this W squared will have its own definition called heat flux. So this is the heat flux. So we plot everything in from this equation to this. So we have this thing will be U squared plus 3 half P, because this instead of IJ will become II. So this term will become 3P over MS NS as argument I made here. So this is a DT term, and another term we just put all 6 those terms in it. So here U squared and 3 half PU and UP, and that define Q. And this term and that term will just put right down here. Because, and also of course the average of V is U. And we know we can split the pressure tensor further into a diagonal term, which is the pressure multiplied by identity matrix, and pressure and the stress tensor, which is off diagonal of the pressure tensor. And so if we do UP, it will end up become PU plus U pi. So we put this in. So this stays the same, and we pretty much just add this to here. So this will become, we add at 1, so it will become 5 half plus U pi. So and we define this term as Q, energy exchange density. So here is our second moment of a fluid, second order of fluid moment. So far my understanding of each term, this term obviously is a kinetic energy. If we do the dt, then it becomes the rate of changing kinetic energy. And this is the kinetic energy dot multiplied by U, which you can think it as a flow of a kinetic energy. And this is a stress tensor, and this is a heat flux. Basically, the exchange of a heat instead of kinetic energy. Basically, one is U, another is W. U is the kinetic. This is heat. Q is heat. And this is energy change due to QE, basically electric field, electric force. If we have with this physical understanding of conservation of energy, the E cross B term, V cross B term vantage makes sense now, because we know that the Lorentz force doesn't do work. So we only have the electric field term, and this Q is an energy exchange density. You can think it as an energy change due to collision.